Okay. Well, hello everybody. Welcome to our NICE talk, the 127th NICE talk. So today we are pleased to have the authors of this interesting paper, Measuring Agents in Production. So I guess during the past 1 or 2 years, there are lots of attention and efforts on designing agents and improve the agent capabilities in the research community. But I think one very interesting question, I think as a researcher in any field should always care about is that whether this kind of research outcomes really be able to use in production and how is the status of them in production. So I think this paper is provides us some very interesting insights by taking a very large scale survey and some in-depth interview with a large amount of real world production owners. So we are very excited to hear Melissa and Negar today talk about what we found in this interesting project. So let me quick introduce our two speakers today. This is also our first time we have two speakers. Melissa is currently a Ph.D. student in computer science at UC Berkeley. She has lots of research interests, but I think her interest is mainly around efficient and sustainable computing systems for emerging ML and data-intensive tasks, especially at a large scale. And also, she's an Amazon AI Fellow and Model AI Resident. And also, Negar, she's currently a postdoc in CS at UC Berkeley in the same lab as Melissa. She also she obtained her Ph.D. degree at University of Waterloo, and actually that's a time like we met with each other. And also like her interest is in the intersection of information retrieval and LLMs, especially on how retrieval should be designed, evaluated, and integrated into larger model-based information access systems, and also how can the larger model be used both as subjects of evaluation and as evaluators in the modern IR pipelines. And I am today's host. My name is Haolun. I'm currently a final year PhD student at MILA and Mcgill University. And I was a business scholar at Stanford. And my interest is mainly on trustworthy AI, human-centric AI, and personalization, etc. So without further ado, I guess I will stop sharing my screen, and Melissa, you can share your screen to start your very interesting talk.
Okay, yeah, thank you. Can everyone see my screen? Good? Okay.
Yes, we can see the screen.
Okay, yeah. Okay. So hello everyone, and thank you, Haolun, for inviting us. We are very excited to join the NICE series. So yeah, we are very excited to share our latest work to the community. I'm Melissa, and my co-author Negar is here with me today. And then we'll be sharing our work, MAP, Measuring Agents in Production. So this is an exciting collaboration between various labs at Berkeley, Stanford, UIUC, and our industry collaborators. Okay. So let's pose a question to the audience. Have everyone noticed a shift in trend where people stop asking if agents are real and whether if they have any future into how can we build more effective agents, how can we build more efficient agents into the real world? So people say last year, 2025 is the year of agent, and then this statement still continue to hold true in 2026. But throughout the year, we have seen some questions and debates on say whether if agents actually create real values in the real world. For example, there's this report from MIT that shows that more than 95% of agent initiative fell from the perspective of business executive on agent deployment in terms of return on investments when they are getting put into the real world. So there are a lot of questions about what separates successful agents from failure deployment. So the stark contrasts, there are a stark contrast between all of the excitements that we are seeing versus what people are seeing in reality. But unfortunately, there are very little public information available that give a holistic view into the current state of production agents. Right. So here today we are presenting to you MAP, the first study that offers critical visibility into understanding the reality of production agent, where we provide first-hand data on the technical details from practitioners who actually build and design production agents. So, of course, there has been a lot of wonderful and very important work from our community from in the past. Like there are many works that sort of coming from a more business angle, looking into the commercial agents, and then like say from the perspective of business leaders and like whether if agent creates value. And then there's also a lot of important work on agent survey that sort of look into past literature onto like say how agents sort of work. And then there's also like important work where like say are either coming from industry, like research lab, reporting how like they built their agents. But our study sort of differ in the sense that we provide a holistic view on like how agents are being built across diverse applications, and also from the perspective of people who actually build agents. And then we get these firsthand data from the practitioners. All right, so what is agent in the study? There has been like a lot of discussions about like what is even agents. Here, we broadly categorize to have like a few characteristics that's needed. So first is like it has to be able to perform some autonomous action on behalf of the human user. And then like it's likely powered by having some foundational models like large language model, and it's integrated into some form of like software system. And it typically are been built with like having say task specification, some solution generations, and some verification process to evaluate whether if the results are good. All right, so back to the study itself. Here we really try to answer 4 research questions. So first is that like why people build agents, specifically what are the applications, users, and requirements of agent. Then how to build agent, specifically what are the models that people use, what are the agent architecture, and what are like the technical methods that people use in ensuring like successful agent deployment. And third, how are agents evaluated so that it is production grade, production ready? And then last, what are some of the top challenge in building agents so that it's like ready for deployments? All right, so you may wonder, okay, we said a lot of productions agents and deployment agents, so what do these terms really mean? So in our study, we exclusively only include the systems that are either fully deployed in live operational environment already, that are already being used by the end user, or the ones that are already deployed to control users group for piloting phase. So this means that we do not include agents say that are still in development, prototyping, or like sales demo stages. All right, so to do this study though, it's actually surprisingly non-trivial because so in order to do that, our team ran 2 studies. First is a large-scale public survey where we distribute to technical agent builder via like technical events like Agent Summit, our Berkeley retreat network, where we get more than 360 responses, with 86 of them explicitly reported that their system is already in the deployment stage. Then we also went after the hardcore agent building team that are publicly well known to have successful deployment to conduct in-depth interview for like an hour long on average. And in this paper, we include 20 cases that are selected to cover, say, application diversity, organizational maturity, and global reach across 5 domains. So we cover things like from startup that already have real users to like global level enterprises. All right. So now I will pass it to Negar to get into the interesting part about what are like some of our research findings for these questions.
Thank you, Melissa. Okay, so the research questions that you want to explore in this study is that the first question is, what are the applications, users, and requirements of the agents? And basically, why do we need to build agents? The second research question is, how do we build agents? Like what kind of models practitioners usually use? What kind of architectures are most common? And what are the common techniques to build deployed agents? And the third research questions that we want to dig into is that how are the agents evaluated, especially the ones that are deployed? And lastly, what are the main challenges when we want to build deployable agents? So the first research question, we asked participants, why do you build agents? What are the main benefits that you gain from building agents? This figure, as you can see here, shows the benefits that participants claim to get from their deployed agents. In fact, we realized that organizations adopt agents to solve immediate operational problems. For example, expert expensive manual work, or when they have staff shortage, mostly in tasks where productivity gains are easy to quantify. For instance, reducing human hours could be one, or and like when it brings benefits for the stakeholders. As you can see, increasing productivity was claimed as one of the most benefits that they gain from building agents. On the other hand, in some like aspects like risk mitigation or like faster failure response time, these were the benefits that maybe the stakeholders or like practitioners mentioned less common of why and what motivates them to build agents. The next question, we looked into applications of agents. This was perhaps one of the most exciting and surprising findings from MAP, that we found that agents are indeed way beyond just coding and math, which everyone believes so, that like agents are only for like code generation and etc. But in fact, there are many applications that already agents have been deployed into. Let's look at this figure together. The most common categories, surprisingly, the first most common categories or domains was finance and banking, followed by technology as the second top cluster. And these two have the most real-world use cases for agents. However, the good news is that we see a long tail category of others, which the other category includes things like travel, beauty, legal, defense, and so on. So these domains signal us that there is a lot of upcoming agent adaptation, and this sounds very exciting because it means that agents are delivering real life tasks, and they're way beyond just some reasoning tasks like coding and math. Okay, and then the previous figure was the results that we had from our survey. Also, in our case studies and in our interviews, we also tried to interview diverse set of applications. As you can see, we interviewed people from business operations, communication, scientific discovery, software DevOps, and etc. The findings from our case studies and from our interviews also confirms that the production agents target productivity gains through automation, and they focus on measurable improvements. So let's walk through one of the examples of our case studies, or like use cases of agents, which is an insurance agent workflow. Don't worry about understanding this complicated figure. What I want to tell you about this figure is that this is a workflow of an insurance agent. So we have one line of agents that focus on financial aspects, and the other line of work is fully focusing on like clinical condition analysis to make a decision to confirm or disapprove this case for the insurance. So this means, so does this mean that agents are replacing human workers like by automation? Do we mean that agents are replacing humans? The answer is no. Agents are not replacing humans. Rather, they primarily serve humans. So in our study, we find out that over 92% of agents are collaborating with humans. So it means agents working with humans, and only 7% of agents are working with other agents or other software. So agents are primarily collaborating with humans. Okay, so let's now talk about application requirements of agents. Given these are the applications of agents, what are the requirements? For example, let's talk about the latency objective for agents. You might think that, okay, agents might take too much latency and they might have latency problems when you want to build agents, but surprisingly, we found out that there is a very high tolerance for latency requirements. When agents are running, here, as you can see in this figure, agents can run in order of minutes, hours, or even days. And their latency tolerance is pretty high, and they focus on output quality with relaxed latency requirements. But why is that? You might think that why people give high tolerance to agents. Okay, why having slow agents are okay? That is because even if you have the best model, and let's say best off-the-shelf model, it might take 5 minutes for the insurance agent to do this task, whereas for a human expert, let's say a clinician wants to compile all the documents and submit the request, then another insurance personnel should do the intake and do all this manual checking to make the decision to whether approve or disapprove this task. Based on our interviews, they mentioned that this case might take from 3 days to 15 days, whereas even with your insurance agent, even if the latency from software perspective is high, it only takes less than 5 minutes. So what does this mean for us as researchers? Having high tolerable latency means that it opens lots of optimization opportunities based on agents' real-world application needs. For example, there can be a lot of room for doing research on new scheduling and inference opportunities. Okay, now let's move on the second research question, which is how to build production agents and what are the most common practices in building agents. So, how do people start building the agents? Is probably many people start by working open frameworks or open source frameworks for building agents, the third-party frameworks, and some people try to have in-house solution. Let's look at this figure. We asked if practitioners use any open source frameworks or they have in-house solution. The bar on the right shows that 60% of our participants use open source frameworks like LangChain or Llama Index, QAI, and etc. However, the bar on the left, the blue bar, shows that almost 40% have in-house solution for building frameworks for agents. But I have to tell you that here our case studies and our survey data is a little bit contradicting to each other. While in our survey, many deployed agents declared to use third-party open frameworks, in our case studies, 85%, within our interviews, 85% claim that they have fully in-house agents. But why is that? They mentioned that in our interviews, they mentioned that initially when they were prototyping, they preferred to use open frameworks, but then for our production, they switched to having in-house solutions. And one reason might be, one of the reasons that they mentioned is that it has too much of overhead, especially when they face compatibility issues, and it might be an additional dependency to their organization, so they prefer to have in-house solution. But then the takeaway from what frameworks people use to build agents is that they want simple but controllable solutions. And then the next question that you might have probably is that, okay, how do people usually prompt agents? So we asked if practitioners do fully manual prompting. Do they use combination of manual prompting and using AI for prompting? Do they use any prompt optimizer, or maybe they have predefined templates for that? And as you can see, the most common way of prompting across deployed agents declared to be combination of manual prompting plus using of AI, and followed by the second most common way is fully manual. So this means that prompting is heavily centered on human. People get use of LLMs to refine their prompts, but still using fully prompt optimizer or like fully autonomous prompting is far from what is being deployed in reality. And again, this confirms our previous finding that teams prefer having controllable and interpretable prompts, and this will help them to debug it more quickly. And they figured that they think that black box optimizers can be an additional overhead to their systems. So they prefer simplicity over having complex prompt optimizer. The next question is probably the one that you might be waiting for it, because I was very curious to know, and that is, what are the underlying models that people use to power the agents? Here on the blue and green bar, we asked if people use open source model or closed source model. And as you can see in our interviews during our 20 case studies, we figured that most teams use proprietary frontier closed source model. So 17 out of 20 cases. And we during our interviews, we realized that people prefer to go with the strongest model, and those 3 cases which they prefer open source model over closed source model are those that they find out either the inference cost is very huge, or either they have too many heavy inference calls, or they were companies that they had their internal infrastructure, or they had like their own compliance purposes. Otherwise, they prefer to go for the strongest open source model.
Closed source.
We all closed source. Okay, but then does this mean that like they don't care about the money and like having just expensive, strong proprietary model is okay? Going back to the insurance agents example that we walked through, is that even if you run your insurance agents, which had like, let's say we said it had like 5 minutes tolerance, even with the strongest model, it might only cost you a few dollars. Whereas if you have a human expert to do that task, it will take much more, it will cost you much more to go through this case and approve the case. So still, even though you go with the strongest model, it will worth it compared to a human expert. And the second question is that, do teams or practitioners do post-training or not? Among the 20 cases that we interviewed, we figured that post-training is not very common. In fact, 14 out of 20 teams do not do any post-training. They find out that current model capability is already good enough for their task. And even among teams that do post-training, 3 out of 6 cases, they do it selectively, only for some clients, or when it only makes sense, like cost-wise and money-wise, it makes sense to do it. So does this mean that we don't need to do any research on post-training? No, it doesn't mean that the post-training is not useful, but it means that current models are already good enough for many exciting use cases, and maybe with more sample efficient post-training, we see that like the next generation of agents use most post-trained model, and maybe right now in like they're in prototyping or experimental phase. Okay, and next question is where we ask how many different models do you use in your architectural design of your agents. This figure shows the histogram of number of distinct model that they use. We see that like there is a heavy skew towards like using fewer number of models, but there are also cases where even people use more than 4 models in their agents. But during our interviews, we realized that that's not only because of the functional need. Sometimes people use more than one model because of operational requirement. For example, it might be a case where they were using with one model and that model got deprecated, so they have to migrate to another model. Another use case might be that in an organization, different people with different roles have different access to different models. For example, interns have a different level of access to a few models, whereas like software engineers or senior people have access to different models. That's why operational needs requires that you might want to have more than one distinct model for your agent. And next, we asked. Now let's dive into the architectural design of the agents. So we asked how many steps your agents can run before having any human intervention. So how many steps your agents can run independently. And this histogram shows number of steps that an agent can run. And again, we can see that there is a huge skew, and like there is also a long tail distribution towards having a fewer number of steps, which means that people try to not give full autonomy to the agents, but also their autonomy would be tightly bounded with fewer number of steps because of they want to avoid having problem complexity. And again, here is another confirmation that deployed agents needs a lot of simplicity, and currently simplicity wins over complexity for building agents. Okay. Yeah, okay. So the takeaway from how to build, like what are the common practices and how to build agents is that people prefer having controllable and simple methods, and automating repeatable workflow is the key to building agents. Okay, the third research question. How can we evaluate agents, and how are the current deployed agents being evaluated? So we asked practitioners, have you ever compared your current agentic method to a non-agentic baseline? So here we can see that only 38% of participants compared their solution, their agentic solution, to a non-agentic solution. And 61% of them did not even compare their agentic solution to any non-agentic solution. However, among those 61%, we realized that for 25% of them, like an alternative non-agentic solution does not even exist. So this means that they're working on a new problem or like new product that there is no alternative solution. They don't have any baselines to compare with. But 35%, even though they had any baseline, they preferred to not go with that. And at the end, 82% decided to go with the agentic approach, whether or not they compared with a non-agentic or alternative approach. And we also asked like how agents are evaluated for deployment. What are the main ways of evaluation? So the main ways of evaluation was, the first one is like, did you do human in the loop and manual verification? Do you use model-based evaluation like LLM as a judge? Do you do like cross-referencing, things like RAG or referencing to knowledge graphs? Or if you do rule-based checking, or none of the above, and you have another way of evaluation. So interestingly, the most common way of evaluation, we find out that it's manual human in the loop evaluation, and it will be complemented by LLM as a judge. In fact, when we looked into our data, we figured out that the LLM as a judge, like people do both of them at the same time. So they use LLM as a judge as a complementary method to human in the loop. If we go back to our insurance agents one more time, an example of how LLM as a judge and human works, this is a great example to understand it, is that when a user sends a request, the insurance agent will make a decision, and it will give us how much confidence they have in that decision. If they approve the case, let's say they have a confidence of over 95% that they approve the case, or their confidence is not too high. If the confidence is not too high, then we will have a human expert to review it. So that's how an LLM as a judge is working with the human. And even in the case where they approve with high confidence of over 95% confidence, human expert will sample 5% of the data and do a manual review. So that's how manual human in the loop will be accompanied by LLM as a judge for evaluating deployed agents. Okay, so now I'll give the floor to Melissa to continue the research questions and close the talk.
Yeah, so thanks, Negar. So now we know how agents are being built, evaluated, and then like what are the applications and requirements that they're built for. So let's now look into like what are the top challenges that the development team encounter while they're building production agents. And guess what? Reliability consistently remains as the top unsolved challenge across not just like the deploy agent, but across all stages of agents, even for the ones that are already in production. So like what do we really mean by reliability here is that like first the agent has to work correctly like across a long like period of time, like by the standard IEEE definitions of reliability. Okay, so you might then wonder, well, isn't there is a paradox? Like we are saying that agents are unreliable, but then they are still in production already. So how does that really work? And it turns out that practitioners, agent builders achieve reliability, like not through model advancements or algorithmic advancement, but through like very careful system level innovations and constrained deployment. So here are some of the development patterns that we observed from talking to practitioners on how they ensure reliability in agent. So for example, people deploy read-only agent. So what does it mean is that like it could generate a report on the plan. So the example here, which like we did not include in the slide, but you can refer to our paper, is like a site reliability engineering agent. It has like access to like examine the logs and bugs across stack, but it wouldn't make any state changes to the real system. It will only generate an action plan for the human expert, which are like the actual site reliability engineer in this case, to take the action. And then another deployment paradigm we saw is like people deploy agents with write access into a sandbox environment that are specifically built for agents to use. So this means that agents can do like trials and errors and are able to make safe mistake in the sandbox environment until they come up with the right decision or the right behavior. And then this final agent generated output will go through very rigorous testing and verification pipeline before it got merged and deployed into the production environments. So this allows agent to take some actions to change the state, but without directly impacting the deployment environments. And then another two paradigms we observe is that sometimes people build an abstraction layers or a wrapper API around the real system, so that even if the agents are not reliable or like make some like mistake, like it doesn't expose how the real system look like. And then finally, like people deploy same role-based access control to the agent, so then the agent just doesn't have access to do certain actions. So the key takeaway is that people currently like achieve reliability and security through these operational constraints. And if we look at the figure on the right, like it shows like what are some of the data that currently agents are working with, and we see like there are a lot of like live user data, and some of them are confidential as well. So also like people like right now practitioner achieve security and reliability with these like practices that we saw on the left, instead of like having any algorithmic innovation. All right, so another thing then we ask is that, as Negar showed earlier, some people have like more lenient latency, but some people may not. So we want to know like how much latency affect deployments. And we show that only like latency is only a blocker for 15% of the agent application. And so we wonder like why is that? And then when we look underneath it, the data and then talk to the actual practitioners in interviews, we found out that there are actually new development paradigms where there are some agents that are being deployed as asynchronous agents. So it means that the agents can go take off and then do its own thing before coming back to the user. Like the insurance example that Negar showed is a perfect example of asynchronous agent that doesn't rely constant human interaction. And then some example of real-time agent is then say if you have a phone call agents where the human need to constantly talk to the agents. So then in that case, latency will become a friction. But in general, we found that right now, agent applications are more so targeting the applications that are more latency tolerant. And then this also partly includes deploying agents for internal users. So they're also a little bit more relaxed. All right, so another top challenge that we observed are evaluations. As Negar was mentioning, like say some people don't do evaluation or comparison with benchmark. It's not necessarily like that. People are like lazy or like they would be like, oh, agent is flashy and cool, so I want to try it, but I don't evaluate it. It's because evaluation is just naturally hard. So what does it mean is that we see many of the agent use cases are deployed for a highly customizable use case. So it naturally means that it's a very niche application, and then whatever benchmark and evaluation built for that is not very reusable for other use cases. So we talked to a lot of agent team where they have to like do manual evaluation, do A/B testing because these benchmark just doesn't exist, or it's very hard to create, which some team do went down the route to create their own benchmark, can take them like months to build. And then another reason where evaluation is naturally hard to do is because agents are now being used to tackle many like interesting real world cases, but then that naturally means that they have delay or delay impact. So it means that verification is very hard to measure directly. So for example, back to our insurance agent use case, right? If the agent made a wrong decision and then it might take days for the actual patient to escalate the case and then to raise that, okay, this decision was wrong. So even if practitioner or us as researcher did all we can do to evaluate the agent output, there are still some cases where we cannot get immediate feedback. And so that's why we see that there's still a very heavy dependence on having human in the loop to do verification. All right, so there we are. These are the findings of our 4 main research questions. So for RQ1, we see that what are the applications, users, and requirements of agent? We see that there are a lot of diverse applications across 26 domains already. Most of them are now being built on very measurable metrics such as productivity gain, reducing human hours, reducing costs. The agent now mainly serve human users and are targeting a lot of relaxed latency application. And then the second question is how are agents being built? The central theme is that people now very much prefer simple and controllable methods that can effectively get the target task done because it's controllable, and then we need reliability. And then the third one very much follow the same theme, that human remains central to production evaluation. And then lastly, we observe that reliability is the core and solve challenge that are key to agent success. All right, all in all, we are very excited to see the diverse applications that practitioner is able to enable with the current model capabilities. So we saw a lot of interesting use cases with agents that are heavily centered around test input with natural language or code. And then excitingly, our survey shows that there are a huge interest that practitioners want to support new modalities such as image or video in the future. So very excited to see these new agent application coming up, which shows there are opportunities for practitioners to build more agent, and also a lot more opportunity for us as researcher to do research in these area with new applications, new usage paradigms. So yeah, knowing that is very exciting. So that sort of leads to how do we interpret map data? What do we really do with it now that we know around 17 design space that we list out in the paper? All right, so the first central theme is that there are a lot of surprising finding, at least to us. For example, practitioner rarely use RL and post-training in production. But it doesn't really mean that these are not useful, as Negar mentioned, but rather it signals that there are underexplored research opportunity to build, say, more sample efficient RL methods that are robust to model upgrade. And then we show that there's this new class of agent applications emerging that are latency tolerant. So there can be a ton of research being done around how do we do schedulings or batching or do more inference time scaling techniques on these type of agent application are super interesting. And then we also show that people are using multiple distinct models. So there can be some interesting things to do, with model serving and inference with how do we, work around with this requirements of needing different models at the same time. And then the second line of theme that map data show is that reliability is the key to success of agents. Currently reliable production agents are achieved through a lot of system level innovation, as we saw. For example, people use agent workflow instead of letting agent to do self-planning. People cap say agent to take maximum 10 steps before human have to intervene. So then this naturally raise new research question: how do we unlock greater autonomy in agent while maintaining reliability? So maybe it informs that a lot of future research that we can explore as well is not to say unlock a few more percentage in your agent benchmark, but look at how can we make agent work consistently across like these type of real life scenarios instead of just on math and coding. And then lastly, we see that the last central theme is that humans are in the loop. They're still in the loop. They're very much still in the loop for production agent in both the deployment part and then also the development part. So for the development part, it's very much related to the second theme that currently a lot of methods are not like reliable in the sense that practitioners lack trust on a lot of black box optimization methods. So currently people prefer like more controllable and simple yet effective approach that can get the task done. So for a lot of research on optimizations, maybe we need to like make the methods more interpretable and then more human workable. And then second is in terms of the deployment pattern. We saw in the example of the insurance agents that clinical practitioners are still very much in the loop of the whole evaluation pipeline. So maybe instead of like going for a full autonomy, we need to think about, say, how should human better augment agents, and then how can agents better augment human? So then like letting humans stay central to the loop as part of the architecture components instead of like replacing human in the full system. All right, so basically we here present to you MAP, the first study that provides a snapshot of the current landscape of production agent from the perspective of practitioners who are building agents. And then we look at the topics of like how people build agent along like around 17 different dimensions. So we hope that this offers researcher visibilities into real world constraints, and then we identify some underexplored research opportunities that we can advance the field of agent together. And then also we hope that this result will be helpful for the practitioners because it shows proven lessons learned and working development patterns from others across like other industry. All right, so yeah, to that, thank you. And then we also have a big shout out to everyone who participated in our study. Like MAP would not be possible without people contributing to open research because these information are typically kept proprietary. So yeah, we are very much happy to chat more if you're building agents or evaluating agents. And I think we can now open the floor to questions.
Thank you, Melissa and Negar, for the fantastic presentation. I think this is a really interesting project, right? It will basically bridge the gap between the research community and the real-world production. And also, as you mentioned, I think, yeah, I guess I will use the privilege of as a host. I will ask my own questions first, and then I will see if there's any other questions from the audience. So I think as you agree, like for instance, there are some surprising finding, right? For instance, I think the most surprising finding to me is that latency actually is not that important. And also, I think there's also some other findings, as you mentioned, like I think the controllable and the simple design is the most important thing.
Yes.
And also, I think especially you talk about the reasoning step, right? So basically, I think based on this, we can see maybe those successful agent deployment, I guess you can call it as a constrained autonomy, right? So it is, for instance, it's follow fewer than 10 steps. It's follows a static workflows or something.
Yes.
I just wonder, how do you view this kind of constrained autonomy? Do you think it's generally widely used design principle for any production system, or it's just a transition strategy until we have better evaluation and reliability method? So I just wonder how you think about this.
Yeah, I can start, and then Negar you can like add on to me afterward. So that's actually a wonderful question. So like basically, like if I can like have one summary of the question, it's like what is the causality between what we observe and then the underlying principle? Like, so you first mentioned like latency, right? So I do like agree that there can be two way to sort of like understand the data. So the first one is that it is true, like from talking to like some practitioners, which the data are not included in the study, is that they try to deploy agent, but the latency is just so bad that they just simply could not like use that for their current application. So there are these class of agent where they need this real-time responsiveness. But then like because of that, they currently cannot deploy agent because agent like are like not like, as we saw, like many of them are operating in like scale of minutes. So that is one case, right? Like people, like there are the class of people who do need like sub-second or second level latency, but then they currently cannot deploy agent. But the more interesting part, at least in my view, is then it shows a new trend of like a new class of agents, like basically the one that we saw that are like asynchronous agent, or the ones that are more latency tolerant, because these are the agents, I guess, at least that are less common to everyday life or to me, because like when the whole agent paradigm sort of started, I guess like at least to me, it's like I'm more so closely interacting with say coding agent that will like come back to me like say in a few minutes or whatever. So like I actually don't really directly interact with a lot of these like automation agents that are sort of working behind the scene. But then like from map, we show that, okay, hey, like agent as it is right now are actually creating values in these domains because people found nice use case for them. So for these ones, there are like, you know, its own distinct optimization opportunity for this class of agent. So that's like this like sort of same idea sort of apply to like the autonomous agent as well. Like we say people now letting agent to take like say we show that at most 10 step, like there's like 68% of them before like human intervention, right? So that's like kind of like the same, but like I feel like agent structure workflow is slightly different in the sense that like human have developed like nice workflow and like we have nice insight from doing things for many years. So it might make sense that there is still some human knowledge distilled in the agent system by having some sort of workflow. But I mean, this is just me speculating now, that like say this abstraction layer may go higher and higher as the model is getting better, or we might let the agents to take more step as the model is getting more reliable. While we have more like better methods into like evaluating them and verifying them in runtime. So yeah, I think like they're all related. It's like both like how we definitely show this is how agent currently work. We are not saying this is how agent will work in the future. And then we hope that like, you know, knowing how agent currently work, we can identify some research to unlock the next wave of agent.
Yeah, just to add is like I also think like I agree with what Melissa says, and also like what Haolun was suggesting, like as the second point of view, that I think the autonomy is founded because of reliability issues, like to secure the reliability. Once we can have better reliability, then there is maybe no need to have necessarily bounded autonomy for agents.
Or like the bound is higher where they can take
bound is higher. As the reliability goes up, the bounds will be also high. Yeah.
I would agree. But maybe I think one interesting follow-up question is like, how do you think in the future, for instance, what kind of signal can tell the practitioners that it is safe to relax these constraints? Like for instance, I mean, I think it's still difficult, right? Like for instance, I mean, both the reliability and the evaluation should both goes up. Like for instance, if this, even though the system's reliability goes up, you have to have a good way to evaluate, like to reliably tell you that its performance, its reliability goes up. I think it's still interesting, a bit challenging topic, right? The signal is not clear.
Exactly. I think that is a very interesting open research question on its own. I guess like one thing like as we like sort of like highlighted is that like how do you like evaluate like the impact of agent? Like it can be very hard when it gets put into real life because there's this like delay like feedback, right? So like we kind of like don't really know, like even with customer support, like you don't really know if your customer is happy or not unless they like say stay on the call for 5 more minutes to answer the question or whatever, which at least I don't really do that.
That's true.
So yeah, like even like knowing like what are the signal to look into, I think are like incredible interesting research area to advance the field of agent.
Yeah, exactly. And maybe a fun question here, since I think you just turned to page 34, like about the reasoning steps. I think there are some uses about Okay, page 34, maybe the next page. I think there are some cases using hundreds of thousands of steps. Like, what are those productions?
That is very good question. So one unfortunate thing is that our survey, so this data is from our survey, so it's fully anonymous. So
Okay.
So at least from these figures, we don't really know what are those specific use cases. But from talking to the practitioner, like our 20 case study, so there are applications that are where agent can actually take a lot more steps, not in the like the scale of thousands, but like at least in the scales of like tens to hundred. So those ones are like sort of like the typical ones where they can sort of like run in the sandbox and do more things to do exploration before like coming back to the human expert for feedback. So like that sort of like allow the agent to take more steps. But yeah, I would also be very curious to know people who allowed their in like steps of thousand. Like if there are anyone in the audience that are building agents with like thousands of steps, please talk to us. We would love to learn more about that. Yeah.
Yeah, this is super interesting. That's cool. And also, I think maybe we can also have some discussion on the evaluations. I think, as you say, like it's still human centric. Like you say human in the loop, right, for the evaluation. But actually, I mean, I don't think this is a really good way to scale up, right? I also read your paper actually, so I think you draw an analogy between some agent errors with the silent failures. You said like where the success signals often come too late, right? Until you have some financial loss or customer churn.
Yes.
So I guess like maybe in the industry there's a trend like because we can't trust them at the compile time, so maybe we can only monitor the agents in runtime. So I just wonder if you analogy to the traditional software, we have the unit tests.
Yes.
So in your view, do you think we can build some unit tests for this non-deterministic agent? Like, is it possible to build something like this so we don't really need too many humans in the loop?
Yeah, so that is a very good question. So one thing that we should highlight here is that there are evaluation for the development case, which is the offline evaluation. And then there's also the evaluation for the online case, which is like at the runtime, how do you make sure that agents sort of work well? The data we are showing here is actually like we are not differentiating between the two particularly. But in terms of like evaluating agent performance with like say some unit testing, I think like people are actually already doing that. Like I cannot say that everyone does it, but like many people are like sort of having their evaluation test suite for building agents. So like we were talking to some practitioner where they like, for example, already had some traditional software system that existed where they had test cases for it. So then they would try to like adopt that for agent use cases. Of course, they ran into a lot of challenge because like agent can have undeterministic behavior. But then like people are actually already using those cases, like not a lot, but like people are like doing that, especially the enterprise ones. And then, but like, I think like the bigger question though is that like, a lot of like basically the underlying behavior principle change, right? Because like for like traditional software engineer, if you have good enough of like the unit test, like the functional verification test, the system level verification test, you have a pretty good confidence level on like how well your system will perform. But for agent, because it can like get different input, and then like because of the natural like because the characteristic of like say LLM, it could have different output with like different inputs. So then like it's very hard to be exhaustive in test coverage. So I guess like that is also one of the reasons why we see there is this like new sort of like requirements for this class of application, right? Like agent application that people need to do online runtime observation and observability, which I think which itself is also a very interesting research area that we kind of highlighted in the paper as well at the end, that like how do we like monitor agent behavior at runtime. So that's why like this question itself is also like a new research directions, because like doing full CI/CD is like not, at least right now, like it shows that it's not fully possible to do for agent.
Yeah, fair enough. Okay, so maybe we can go beyond the time a little bit because I just realized we have 3 questions from our online audience.
Happy to take
The first question is about like what RL techniques are used for fine-tuning agents in production to further improve the system? What feedback technique is used for continual improvement of the system? So do you have any response about this?
That's a very good question. I don't think we have answer from the study to that question. Like people did not share specific details of like specifically how they did post-training in our interviews with them.
The second question is like, if people are not doing post-training, so how do they build data flywheel that can keep improving the agent in the long term? Or they just expect the base API will get better over time?
That's a very good question. So like basically we see that a lot of people right now would very heavily optimize on the prompt of the agents, like without using prompt optimizer as we show, but a lot of people like they have very dedicated like team of people who would work on like building and evaluating the prompt for their agents to ensure that it worked for like their target use cases. We even saw like some people would like say, I think this is becoming a new trend. Like I believe it calls like forward deployment engineer, like where they send people to like their client to work with their client to make sure that their agents like work well with their client use cases. And one of the job role in like or like one typical duty in this role is to like tweak the prompt to work well for their case.
And the last question I have now here is, are there any indicators you found into cases for not using agent? So for instance, what can we look for pre or during early development to not continue with the agent? Is there any insights about this during your interview?
That is a very interesting question. So first we try to talk to people who build successful agents. So that naturally means that we mostly talk with people who, build successful deployment agent. There are teams that we actually talk to, which like are not included in the paper like naturally because like they decided to not continue with agent. Like I mean there exist case for those as well. I don't know if we can share too much about those cases, but basically people like find that like I guess the central theme is that people find their original system already kind of work pretty well for their use case, so like there's no need to like migrate to building agentic system. But of course this has the premise that like I guess this is like some existing company has some existing process. They're like evaluating if they want to use agent, then they find out okay it doesn't really need agent. So I guess it biased towards those cases is like not a general statement.
And I think like just to add it that we also in the paper we have the data for our full survey, which includes some agents that are researchy or in prototype and have not been deployed. So I'm assuming some of the agents that are in the prototype or research stage right now, or research phase right now, they don't find their way into deployment. But what's the reason for them? We are not completely sure, but we also have some analysis on differences between deployed and non-deployed agents based on our survey in the paper. So those might cause like some hypothesis for why those agents didn't find their way into deployment, but we cannot tell for sure.
Interesting.
Yeah, for example, we show that in those like non-deploy agent, there are more people using post-training.
Also they use higher number of steps. Like they give more autonomy to the agents. Like those are clear differences between our deployed and non-deployed agents data.
Yeah, but the causality we don't know. Like, is it because there's development or because they did this so it didn't reach deployment? Yeah.
Very interesting. I guess I still have more questions, but I guess because of the time we can stop here, so we can discuss offline if possible. And thanks again for Melissa and Negar for coming to this nice talk and for giving this presentation. And also thanks everyone for coming. I guess we can stop
All
here.
right.
Thanks
Yeah,
everybody.
thank you so much for inviting us.
Thank you.
Yeah, and please reach out to us if you have any questions or want to chat more.
Thank you for having us.
Yeah, thank you.
Thank you.
Bye.
Bye.
I guess we can go.
What is your wish? No time to rest. How may I serve? I'll have it up and know someone interested.